Okay, so this video is the 12E handout, which is the first problem deals with a new shape for us, pyramids. So first, a right pyramid is a pyramid that forms that the height of the thing forms a right angle with the ground. So and you have to have a regular shape for the ground, so like a square or a equilateral triangle or any regular polygon. Um, so if you found the center of the point on the ground and you went straight up, you would get the vertex for the some books call it the apex, but the vertex of the pyramid. So this right here forms a right angle with the ground. Uh, so let's see. Some things to keep track of in this pyramid problem is there are lots of different triangles you could end up using. So, for example, there's the triangle that goes from V down to P that goes like to D here in front, right? And if you look at that triangle, that's a right triangle because this is perpendicular to PD, which is located on the ground, so that forms a right angle. There's also any of the faces, and the easiest face to look at here would be this one. So VDC would be another triangle. That one would be isosceles because this side and this side are going to be the same length. There's, if you drew in the height of the face right here, that thing, which is a height that's slanted. It's actually called the slant height of the pyramid. Um, you have then cut this triangle into two right triangles, so you could use those triangles. There's also this triangle here. Whoops. This one to C to there. So that also, in fact, I think there's a picture of that one down here somewhere. This one. That's also going to be a right triangle right there because this is perpendicular to the ground and PC is on the ground. Okay? So, and then this is a view of the base. So we'll be using all these different things here. Okay. So let's take a look. Find the length of a base edge. We know that the base is a square, and the square has an area of 196. So this area down here is 196. So the area of the square is 196, and we know that the sides of the square are all the same. So if I call them x, it's x squared, and so if I take the square root, I get exactly 14. So 14. Let's see. It was centimeters squared, so these are centimeters. Is the side of the square. Okay. So let me just put 14 here, so we have it. And then down here, I'll label some more of them. So 14. This whole length is 14. I'll put them here too. And then I'll put them on the direct view of the base as well. Okay, so let's come back up. Find the lateral area of the pyramid. All right, well, oh, and a lot of students miss this, even though it's bold, underlined, and I tried to make it obvious. Assume the pyramid has a total area of 896. So total area for a pyramid, it's the area of all the sides, which in this case is 4 triangles around the edge, around the sides, plus the area of the base. Now, in a prism, it'd be the base is, but since it's a pyramid, there's only one base. Okay? Well, I just want the lateral area. The area of all the sides is the lateral area. Right? So, let me write total area equals lateral area plus area of the base. And we know some of these things. We know the total area is 896. The lateral area we want, and the area of the base we know was 196. So then if I subtract, I get that the lateral area is going to be 700. So down here I can fill in 700. And since everything was in centimeters, this is centimeters squared. So this is part B. And let me shrink this down because I might need more space. Okay, so part C says find the area of one lateral face. Well, if you think about it, since it's a square on the bottom and each square has a triangle coming out of it, there are going to be 4 lateral faces. And since it's a square, all the sides are the same, 14, 14, 14, 14. So all of these triangles are going to have the same height, or same area, So for C, I got 4 triangles. So the lateral area was 700, which is really the area of 4 congruent triangles is 700. So if I just wanted one triangle, area of one triangle, that's going to be 700 over 4. And if you figure that out, you get 175. So the area of one triangular face, one lateral face, is 175 centimeters squared. Okay, let's take a look at D. Find the slant height of the pyramid. So here's that. Now, there are multiple heights that you refer to in a pyramid. The main one is the actual height of the pyramid, right? Straight up and down. This one right here is slanted, and it's the height of the triangle. So the height of the triangle is actually called the slant height of the pyramid. Slant height. And if you think about it, it should make sense. It's the only height that you're looking at that's actually slanted at all. So this one we know is what we're looking for. So let me take this triangle right here, and I'll draw it with a direct view here. So let's see, the top is V and then DC. V, D, C. And we know that the area of it is 175 because it's one lateral face, one side face. Well, I know that the area of a triangle is 1/2 the base times the height of the triangle, and the height of that triangle is actually the slant height. So let's see, 175 is going to be 1/2. The base of this thing is DC, which is 14. So it's half of 14 times the height of the triangle, which is really the slant height. And that's what we're looking for, but we can solve for it. So let's do 175 equals 7 times the slant height. And then if you divide by 7, you get that the slant height is 25. So now we know this is 25, and then I can go ahead and put it in this picture right here, 25. Okay, so let me put that down here, 25, and then since it's a length, it's centimeters. Okay, so this is 25. Now what we need is the actual height. That's what we want in part E, actual height of the pyramid. Okay, so that's this length right here. Well, notice we got the 25. So what we could do is we could draw this line in right here. Right? Now I'm going to draw, since I don't have a picture that shows this triangle by itself, I'm going to draw it in by itself down here. So here's the base. That's A, B, C, D. And then here's the actual height of the thing. So it's V up here and P down here. And then I'm going to draw in that slant height. And notice that hits the middle of C and D. So this was the 25. And then I've got this line that goes from P over to the middle of C and D. Okay, and then I'll even make it look a little bit more 3D by doing that. Okay, so if I knew the length of P to that midpoint, then I could do Pythag on this triangle. So let's come down and look at what that would look like. So P to the middle of CD would be this line right here. Let's see, I use blue, so I'll use blue here. This line right here, right? Well, if you think about it, that's just half of 14, so that's 7. So this guy right here is 7. So, well, we can do pi tag on that. I'll call this h for the height. So we've got 7 squared plus h squared equals 25 squared. And it turns out if you work that out, you get h happens to be exactly 24. So 24 centimeters. Which means now I can go back and I can write in the 24s for all those vertical lines. This we figured out was 7 there. 24. Okay. In fact, I don't actually need this part because I already have it in my separate diagram down here. Okay, let's take a look at F. Find the volume of the pyramid. On the previous homework assignment, we learned that the volume of a pyramid is the same as the volume of a prism, except you just have to multiply it by 1/3. So it's 1/3 the area of the base times the height of the pyramid. Well, we have all these things. The area of the base was 196, 14 times 14, and the height is 24. And if you multiply those guys together, you get 1,568. So let's go ahead and tack that on down here. 1,568. And this would be cubic centimeters because it's a volume. So then there's one last thing. Find the measurement of this angle, PCV. Well, that's this one right here. So I'm going to call that theta. So if I knew one other side of this triangle, let me shrink this one down. If I knew one other side of this VPC triangle, I could use trig on it. And it turns out you could solve for VC or PC. So I think PC is a little bit easier to look at. PC is right on the ground. It's this line right here. So if you think about this, we've got a right triangle there. This is half of 14, so it's 7. And you could use Pythag, or you could use 45, 45, 90 theorem. Instead of 1, 1, and root 2, it's 7, 7, so it's 7 root 2. So this length right here is 7 root 2. And then you can go ahead and plug that into a calculator when you do trig. So for G, we know that tangent of theta is opposite over adjacent. And then I'll go ahead and do this. So let's call up the calculator. I'll put it into degree mode. And then I want tan inverse of 24 over 7 root 2. So one thing to note, if I do this, 24 divided by 7 root 2, it's not going to give me the correct answer here. And the reason is it's going to do 24 divided by 7 and then multiply that fraction by regular root 2. It doesn't know that the root 2 is in the denominator. So what I have to do is put in an extra set of parentheses for the denominator, like that. So we get 67.585 degrees. Okay, so there's number 1. All right, let's take a look at number 2. Okay, so this quadrilateral is the base of a right prism, meaning that these guys form right angles with the ground, right? So it's straight up and down. And then if you look over here, here's the actual base. This is like the, you could think of it as like a like an overhead view kind of thing. I guess this isn't quite right. This would probably be C here and A here. I think I mislabeled it. So, but it doesn't really matter for the problem. Okay, so find the lateral area of the prism. So you could try to figure out how long this is and multiply it by the height, and then figure out how long this side is and multiply it by the height to get that back rectangle, and then CD and multiply by the height to get this rectangle right here, and then AD times the height to get the rectangle that's like back there that's kind of hidden. But I want to practice a new idea with you. So this one was C, this one was A, which was if I pretend that it's hollow, right? So you've got this hollow shape here. So there's just air inside of this thing. If I were to cut it and unfold it, then you would get this long rectangle that looks like this. So let's say this is where C is. You go a little ways and then you get to B. And then you go a little ways more and you get to A. And then you go a little bit and you get to D. And then you keep going and you get back to C here, right? So this is CB is right here. And then BA is right here. And then you unfold it some more and you get AD right there. And you unfold it some more and you go back to where C was. Well, this is all one big long rectangle, all with the same height of the prism, 12. So if I wanted the area of all the walls at once, I could just do whatever this is, that whole length right there, times 12. Well, that whole length is the perimeter of the top. So really what I want is the perimeter of this shape right here. So in order to get the perimeter, we need a bunch of lengths. So let's draw in some slope triangles. So there's one, and here's another, and then here's one more, and then here's another one. So that these two here kind of overlap a bit. And if you figure out the lengths, let's see, this is 4 across and 8 up. This one is 2 down and 6 across. This is 6 up and 7 across. And this is 3 across and 12 down. Now, this time we're looking for length, right? We care about how long these things are, not the areas of the triangles. So let's do AB first right here. So 6 squared plus 7 squared is going to be AB squared. So then if you work that out, you'll get AB is root 85. So let's see, that's this part on the diagram, root 85. And then let's do BC. So BC is 3 squared plus 12 squared will be BC squared. If you work that out, you get BC is root 153. So that's this part. So let's see, root 85, root 153. CD here, 4 squared plus 8 squared is CD squared. And that comes out to be root 80. So that's this one, which is, where's CD? Root 80 here. And then 80 is short. That's just 2 squared plus 6 squared is AD squared. So that ends up being root 40 for AD. Root 40 right there. So you could do root 153 times 12 to get this wall, plus root 85 times 12, plus root 40 times 12, plus root 80 times 12. Or you could just add up all the roots first to get the walls all at once. So the lateral area is going to be root 153 plus root 85 plus root 40 plus root 80, all times the height 12. And if you work that out, now these guys, you just make sure you use a calculator. I'm not expecting you to simplify all those roots and then hope that you can combine them. So this comes out to 442.292. Whoop, sorry, that 9 showed up funny. 292. And then there were no units for this, so that's just our answer. Now, if I asked for the total area, you'd actually have to figure out the area of this thing too, and then double it and add it because there's a top, and then there's also a bottom down here as well. Okay. So the last problem, you've got a sphere and a plane that's cutting through the sphere. So imagine you have an onion and you chop off part of the onion. When you look at the shape that you get when you chop it, you get a circle, right? So anywhere that I slice a sphere, I get a circle as a result. And in this one, it says the circle is 6 meters away from the center of the sphere. So let's see. We know that the radius of the sphere is 11. And the goal is to come up with the area of that circle. So what I need is the radius of it. So I'm going to call the radius of this circle x right now so that I don't confuse it with the radius of the sphere. But if you think about it, a great place to draw the radius of the sphere would be right here, because that's 11. And now I can do pi back. 6 squared plus x squared equals 11 squared. 36 plus x squared will be 121. X squared ends up being 85, so x is root 85. So that's the radius of the circle. So the area of that circle is pi root 85 squared, pi r squared, which is just 85 pi. So that's the area of my circle, 85 pi meters squared. All right, I hope that helps a little bit, and I'll